Autotransformer. Not transformer, Autotransformer. A miracle that no one talks about. How can you have a 25 MVA input and a 25 MVA output, but less than that is seen by the winding of the machine? That is incredible. Let's prove it mathematically, this concept. You probably noticed how fast my video went. It's intentional. You can pause and rewind as long as you want. That's the video. That's the purpose of the video. Let's talk through this. We have a step down transformer on the left and a step out transformer. All the blue are the voltages. Voltage H stands for high. Voltage L stands for low. Same on the step up. So you can use primary or secondary, low or high. It's the same thing. Doesn't matter. On the red, we have a current IH, IL, high side, low side, high side. And we all know the famous voltage and turn ratio formula. The low of a V high is equal to number of turn on the low versus over number of turn on the high, which is equal to current on the high side over current on the low side. You can use primary or secondary, does not matter. It looks quite different than the standard transformer. We have two windings in series here. There's the bottom one and the top one. The bottom one is called common, and C stands for common. It's common because it's shared between the input and the output. The SE stands for series, and it's called series winding because it's actually in series with a common winding. We have the red current, IL, goes SE and IC, and the series one goes to the output. It's called H, stands for high. We also have the voltages in blue, voltage low, voltage SE, voltage common, and the voltage the high side, which is the output. And the green ones just show the winding called C and SE, and then we have the turn ratio, the number of turn on the common, and the number of turn on the series. Notice something quite different. The voltage through the winding are not necessarily the input or the output, so they have different terminology, DC and DSE. We are going to use all those to go through the equation on this autotransformer. What is the ultimate goal of this? We have S input now, 5 MVA, 10 MVA, 25 MVA comes here, and the load is asking for that. How do we find out what MVA goes here, what MVA goes here? That's what I call SWC and SWSE. S is the letter of apparent power, MVA. So all those equations will help us determine SWC as a function of S input, and same for SWSE. First equation is current comes in is the sum of current comes out. IL is equal to IC plus ISE. On top, if you notice, the current coming out, which is IH, is the same one as here. So ISE is equal to IH. And we have the turn ratio voltage and the voltage formula. VC of a VSC is equal to NC of a NSE. I call this equation 1, 2, 3. Something to be careful of is a trap. right? Because the standard transformer says voltage of the input of a voltage of the output, VL of a VH is equal to the turn ratio. That is not correct here. The input voltage, the output voltage are not necessarily the same voltage that goes through the winding. Very dangerous, so it's a no. What is the actual power that flow here? When I talk about power here, I talk about only apparent power because of the transformer. What is the power that goes to this winding common? What is the power that goes to this winding series? S input is equal to VL times IL. That's the formula of the power. We talk about single phase. SWC is equal to VC times IC, and SWSE is equal to VSE times ISC. So we're going to work on SWC first. If you notice, according to the diagram, VL and VC are the same voltage. So I can replace VC by VL. And so using this equation right here, I put SWC is equal to VL times IC. What is IC? I use the 1, 2, 3 equation we found earlier. IL is equal to ISC plus IC. However, equation 2 tells me that IH is equal to ISC, so I can replace ISC by IH. If I get this right here, IL is equal to IH plus IC. Algebra IC is equal to IL minus IH, and I come back here and I replace IC with this expression. So we get VL times IL minus IH, and then I distribute everything. VL times IL minus VL times IH. Bingo! We are getting there. The term VL times IL is the same thing as S input. So I already have S input as a function of SWC. But we're not done yet, because we have another term, VL times IH. So if I could find out a way to somehow to express IH in terms of IL, I will have S input in this equation and my job will be done. So now the next stage is, how can I get IH as a function of IL? What is IH in terms of IL? Equation 1 told us IL is equal to IH plus IC. Equation 3 gave us NC over NSE is equal to ISC over IC. Cross multiply, we get IC is equal to ISE times NSE over NC. We have equation 2 say ISE is equal to the same thing as IH, so we have this at the end. Now we can replace this term here. Gave us IL is equal to IH plus IH times NSE over NC. Then we factor, cross multiply to find IH. They gave us IH is equal to IL times NC over NC plus NSE. Now we can go back here, replace this expression in here, and that's where we get SWC is equal to VIIL minus VIIL times NC over NC plus NSC. We factor, remember VL times IS is the same thing as S inputs. We can factor S input out, we got this term, addition this, and then we get with this formula, SIN times NSE over NC plus NSE. Finding MVA in the common winding is equal to the input MVA times the fraction. This fraction always going to be less than 1, obviously. So what does that mean? That the MVA through the common winding will always be less than the input MVA. That is incredible. That is magic. Pennsylvania, USA, they had an issue with line drop and the voltage was coming here at 92 kV and they needed 115 kV. So they bought an Autotransformer, 25 MVA, 23 turns NSC, NC 92. So input, it was rated 25 MVA. So what is the MVA via the common winding? You use the formula we have here, 25 times 23 over 23 plus 92, we get 5 MVA. 5 MVA. So what about the winding via the series? So if we use VC over VSC, we could equal to ISC over IC, we get this, and obviously this VC times IC is SWC and VSE times ISC is SWSE. So the MVA in the common winding is equal to the MVA in the series winding. So we're also going to get 5 MVA. The load is asking for 25 MVA. The input is providing 25 MVA. So magically something is happening. It's only 5 MVA is flowing through winding of common and the winding of the series. This is incredible. This is magic. No machine works like that in AC power. So what happened? How can you explain that? We are going to find out in the next upcoming episode. Where are the 20 MVA not flowing here? How can 25 MVA can appear in the output? Knowledge is power, and power is our expertise. DJ, turn it up. I am Cherry Passer, and I approve this message.